What we're trying to accomplish, some of the problems we're trying to solve, yeah, maybe I'll take some questions, tell you where we're going to go, and maybe take some questions at the end. So Raspberry Pi is one of these. This is a $25 Linux, ARM Linux PC that we designed here in Cambridge. Now, I guess, the reason we've designed this is we're largely interested in the education market. The Raspberry Pi Foundation is a spin-off from the university in Cambridge. So we're interested in the education market. And the problem we're trying to solve is that between 1995 and 2005 in the United Kingdom, the number of people applying to read computer science and electrical engineering at our university here and at many of the other universities in this country declined by a factor of about 2. So here we went from having maybe 500 people every year applying to read computer science to about 250. And kind of more worrying, this is kind of worrying for us because we're trying to find about 100 students. And if you're trying to find 100 really good students, then it's nice to have 500 students to pick from. It ensures that you can, you're always going to be able to find 100 really talented kids. Now, kind of more worrying for us though than this was that in 1995, the people who we admitted to read computer science in Cambridge or engineering in Cambridge, we could rely on them having a very complete understanding, even at the age of 17 or 18. We could rely on them having a very complete understanding of how computers work. And we kind of felt that one of the, a group of us, by 2005, what had happened was we'd gone from pretty much everyone who came to our university knowing how to program in assembly language to many of the people who we admitted to read computer science at the university, maybe only having done some HTML, maybe only having done some web design. And this is a disaster for us because it means that we have to spend a lot of the first year of our course. We have a 3-year course here. We have to spend a lot of the first year now teaching elementary computer techniques that previously we've been able to rely on the students having learned themselves when they were children. So a group of us here at the university started to look around to have to try and figure out why this might have happened. And the idea that we came up with was that back in the 1980s in the United Kingdom, there were many small 8-bit microcomputers. There were platforms like the BBC microcomputer, the Timex or ZX Spectrum, the Commodore 64, these very cheap, comparatively low-end computers that people would buy to play games on. Or they might buy them to do their schoolwork on. But what all of these machines had in common was that when you turned them on, even if you were going to use a word processor or even if you were going to play a game, they all came bundled with programming tools. They would all be so the first thing you'd have to choose to do was not to program. The default choice on these machines was to learn to program. And as this ecosystem went away, as these computers were replaced by, for children, often replaced by games consoles, by PlayStations and Nintendos and Segas, replaced maybe in the schoolwork area by PCs, what happened was this ecosystem that supported children learning to program kind of just disintegrated. So someone like me, I was born in 1978. I had I bought an 8-bit microcomputer in the mid-1980s. And I learned to program on it. By the time I went to university, I knew how 2 or 3 different sorts of assembly language. Those opportunities were not available to people who are maybe 5 or 10 years younger than me because they grew up owning games consoles, which you can't program, and owning PCs. And the interesting thing about a PC is that although you can program it, most people choose not to. If you want to program a PC, you have to know that you want to program it. You have to go and download tools. You have to go and seek out documentation. So this group of us at the university, we realized we had a problem. This is the problem for our university. Something that's a problem for a university in 1 year, 3 or 4 years later, it's a problem for industry. So because people can't recruit graduates anymore. So a group of us from the university and a group of us from the industry started to look around to decide what we could do about this. And the idea that we had was, can we build a very, very cheap computer? And what we came up with after about 6 years of trying was this. This is, let me hold it, I'm going to try and hold it closer to the camera. There we go. There we are. So what this is a mobile phone chip on a PCB. So in the middle here, we have, let's see if I can do this. In the middle here, we have an ARM-based SoC. Around the outside, we have a display connector, an Ethernet connector, a USB connector, audio and analog television, and on the back an SD card. And the lovely thing about this is because this is built using commodity technology, we can build this thing for $25. We can build it for a lot less than $25, and we can sell it for $25. And we can put one of these in the hands of literally every child in Britain. Now, we launched this at the start of this year. There are currently about 400,000 of these have been sold around the world. We're mostly selling them we're selling them worldwide, but we're mostly at the moment selling most of the volume is going into Europe and North America. And we're really starting to see some progress. We're really starting to make some progress. We're seeing people send us. We have a website, raspberrypi.org, and people send us these pictures of children learning to program. So, I mean, I think this is kind of it's interesting for two. This is interesting, I guess, to you guys for two reasons. One, when I was younger, I spent a certain amount of time working in Mumbai, and my recollection was that. All of the problems that we have in the UK, all the problems that I see in North America, also apply to a very great degree in India. That it's always very hard to find good engineers. Anything that increases the number of engineers is a good thing. So I think it's good from that point of view. But also I think the really nice thing here is this is indicative of the sort of thing that you can build these days with commodity off-the-shelf hardware at very, very low cost. This kind of implodes the notion that a PC-like platform. So this is a machine that plugs into your television. This is a machine. You can see this like the machines in the 1980s. You can see this as a machine that turns your television into a PC, and this is something that you can build using commodity hardware for a tiny amount of money. And what we're really hoping in all over the world, in North America and Europe and elsewhere, we're really hoping that this will democratize access to computing. You can plug this into a network. It works just like a PC. We're not the only people who know how to build these things. And I think that really this is an indication of what the world is going to be like. I think in 5 or 10 years' time, if you look back we will look back on the days when PCs cost, $500. We will look back on those days with amazement that we were ever prepared to pay that kind of money for a fixed location PC. Now, I'm kind of aware that large numbers of people have just walked into the room, so I guess I'll take advice. Guys, what do you think I should do? Do you want me to recap a little bit for the? I'm wondering if we maybe started this presentation a little bit early. Give me some guidance. Okay, let's give that a shot. Okay, so to those of you who've just arrived, my name is Eben Upton. I'm speaking to you from Cambridge in the UK. I'm the director of a charity in the UK called the Raspberry Pi Foundation. We make small educational microcomputers for children. I have one of them here. There we are. And I was just going to talk to, and I've already talked to some of the people who've already been in the room about, I guess, why we've done this. Some of the problems that we are trying to solve. One of the reasons why we think that cheap computers are important. So I'm sorry, for those of you who've already been in the room, I'm going to basically say what I just said, which is we in the UK, and I think this is true elsewhere certainly elsewhere in the West, have got an enormous problem at the moment, finding enough engineers. In particular, we have a lot of trouble finding enough children, young people, who want to be engineers. And we have an enormous amount of trouble teaching them to be engineers fast enough. So we have a lot of trouble. So I used to work at the university here in Cambridge. Our foundation is a spin-off from the university in Cambridge. And we, over the last maybe 15 years, over the last decade and a half, we've seen this reduction in the number of people coming to study computer science at our university. And we've seen a reduction in the sorts of things that they know how to do. So we used to be able to rely on everyone who came to our university knowing how to program. It's a simple thing. We could rely on everybody, every 18-year-old who arrived at Cambridge in early October, knowing how to program, at least in BASIC. And many of those people knew how to program in C or assembly language, Pascal. And we could just rely on this, and this was a baseline. And in the UK, our undergraduate courses are typically 3 years long, and they're supposed to prepare you to do a PhD. So you're supposed to go in 3 years from being a school child to being able to start a PhD. And of course, if you're trying to do this, then it's extremely helpful when the people who come in the door at the start know what they're doing. It's very helpful if they know how to program. Now, in 1995, when I came to university, this was a fantastic situation. You know, we could rely on this. But by 2005, which is when I became personally involved in interviewing people to come to the university, that was no longer the case. We'd gone from an environment where everyone knew assembly language to an environment where most people knew HTML. And this was a disaster for us. This meant that we had to waste a lot of the precious contact time, our 3 years of precious time that we have to turn people into PhD students. We had to waste a lot of that time bringing people up to a skill level that we'd previously been able to rely upon. So a group of us at the university decided that we would try and build a computer that we could distribute to children in the UK. I mean, we were only concerned about the UK when we started doing this project. And in fact, we were only concerned about people who might come to our university. So what we decided to do was to try to build ourselves a computer which was cheap enough and powerful enough that we could give it to children. They could use it to learn to program on. In the same way that when I was a child in the 1980s, I used my 8-bit microcomputer that plugged into my television to learn to program. What we came up with after about 6 years was this thing. We kind of had this idea that the device that we come up with, that we were trying to produce, would have to do 4 things. Right? So firstly, it would have to be cheap. Our idea was that this thing should cost no more than the school textbook. So we set ourselves a $25 price point for this. 2, it would have to be exciting. It would have to do something interesting. And what we've actually come up with, not only have we come up with a computer that costs $25, we've come up with a computer that can play 1080p quality Blu-ray video. We've come up with a computer that has more graphical processing power than the PlayStation 2, more graphical processing power than the Nintendo. So, you know, it's important. It's very hard to persuade children, if you want them to program, that they should buy a machine just to program on. People always buy computers to do other things and then get tricked into programming. That's how I learned to program. So what we have ended up with is a thing that, just like a computer from the 1980s, plugs into your television and has what is, according to the standards of the time, is enormously high-performance multimedia. 3, the thing needed to be extremely robust. Now, we actually distribute this. This is in a little case. So this has got a little case on it. But we've actually been distributing these this year without a case. So this is just a bare PCB. And we wanted this to be robust so that children could put it into their school bags 100 times and not have it suffer any damage. So we had to work very hard on that. And finally, we wanted it to be programmable. I mean, there's not much point if you can't program it. And so what we've come up with is a device where you put an SD card in it, and you can put every programming language you've ever heard of on one SD card. You can put a C compiler, you can put a Python interpreter, a Ruby interpreter, a Perl interpreter, and you can put some of the programming languages that have been developed for children. So obviously BASIC is the oldest of those, but programming languages like Logo and like Scratch, which comes out of MIT in Massachusetts. So we spent about, I guess, 5 years trying to figure out how to build this. We spent 5 years, to some extent, waiting for chips to become cheap enough that we could cheap enough and powerful enough that we could hit our target price point without building something which was very slow and unperformant. We finished our design for this. In the middle of last year. We started selling them on the 29th of February, all over the world. And we sold 100,000 of these on the first day. We've sold 500,000 so far. So 5 months in, we've sold 500,000. We're selling about 100,000 of these a month, which is not very many by cell phone standards, but by the standards of a new computing platform, it's quite impressive. And this is effectively an ARM Linux box. So the lovely thing, so we had expected to sell these to children. What has been very surprising is that we've sold most of these devices to people like you, people like me, adult engineers who want a platform either to tinker on, they want a platform to play with, or they want a platform to show their children. There are a lot of people my age who have children and who've really regretted the fact that there are no platforms that we can use to talk to our children about how much fun engineering is. So people are buying these to use with their children as a teaching aid. And some people are buying them because they make a very powerful industrial computer. So people are buying these to put them in factories. People are buying them to use as media players. People are buying them to do anything that involves talking to a network. It's the Ethernet jack on the end. Talking to a display. It's the HDMI jack in the middle there. And talking to some sensors. And this connector up here is the general purpose I/O connector. So anything that there's a wide range of industrial applications which are slightly more than you could hope to do, say, with an Arduino, with one of the existing, an Mbed or an Arduino, or one of the existing embedded electronics platforms, but which a platform like this will allow you to work on. So it's been a really good year for us. I think we've learned a lot. As I was saying before many of you came in, I think the biggest thing we've learned is that the enormous level of integration available in a modern cell phone SoC allows you to build extremely cheap, extremely performant platforms, which can do things that only a few years ago were multi-thousand dollar applications. So this kind of appropriate innovation, this kind of value innovation, I think we've been engaged in here, I think is a really good template for a way that we can try and create value in the modern electronics industry. Where do we think we're going to go next? I think for the foundation, we've been kind of sidetracked by selling these things to people like you and people like me. Our charity's mission is to try to democratize access to computing, to try to provide children with access to computing so they can learn, so we can solve our problems, and to provide people in the developing world with access to computers. So we're really trying to, as a foundation, return to that mission. We're trying not to get sidetracked by selling to people like you and people like me. Although it's fantastic that people like us find these sorts of platforms interesting. And really over the next year, our mission is to try to get these rolled out into other parts of the world. We don't just want to continue to sell in Europe and North America. And really to focus on trying to develop some of the educational software, particularly the educational software environment, which is required to accomplish our original charitable goals. And I guess that's it. I guess we are, as a foundation, we are, I think I said, surprised by the success of this thing. I should probably say, they are available in India. You can buy them. I would encourage you to visit our website, raspberrypi.org. I would encourage you to visit the websites of our distributors. So they're distributed in India by Element 14, which I'm sure many of you are familiar with. At the moment, these are, I believe, if you order them in India, they are shipped from Singapore. Although I've told you about a $25 computer, by the time you've shipped it from Singapore, they're substantially more expensive than that. We are very much hoping that we are very much hoping that a local distribution network will develop around this device. So we're very much hoping that maybe in 6 months' time, it will be possible to buy these locally in India. Without paying international courier charges. I think at that point I'm really hoping that we'll see the same kind of interest and acceptance in this device in the Indian market that we've seen in that we've seen in Europe and North America. So I guess I'm happy to take questions either about this device or about maybe our educational mission or just in general about our experiences trying to run a consumer electronics company on a very small amount of money. So, thank you. So let's see. Does anyone have any questions?
So can you hear us?
Able to hear me? Can you hear me?
I can, yes.
Oh, cool.
Hi.
So my question is, with one of these devices, you mean a child can just plug it into their TV and program? Learn a programming language?
Mm-hmm. That's the so your question is that how it works? You plug it into your television?
Yeah, using
yeah.
Some
Sorry?
maybe a keyboard for input, and so a child can learn a programming language. You think Raspberry Pi has the
Okay, so this is a we decided to try to produce educational platforms. There's the One Laptop Per Child organization, for example, that's tried to produce an educational computer that has a screen. I guess that for us, our inspiration was those machines in the 1980s that plug into your television.
So you're saying in the nearby future, Raspberry Pi is working? I mean, can it be a portable device which a poor child, say a child coming from a very mediocre family, who can't afford a whole computer to learn to program?
Yeah, absolutely. So this is interesting. So platforms like One Laptop Per Child they have a screen, and platforms like I guess like the Akash tablet,
Yes.
the various IIT initiatives to produce a low-cost tablet for the Indian market, a low-cost educational tablet for the Indian
But the
market.
quality is
They
bad.
integrate a
I've been
screen.
using one. I took one for testing, and the quality is really bad, Akash tablets. So, I mean, the touch doesn't work properly. You have to really press it. I mean,
That might be that. I don't want to say too much about that. I mean, that's certainly my impression that is not a quality product. Yeah, that's not a quality product. But I guess the good thing about those sorts of platforms, maybe One Laptop Per Child is a quality product, right? The good thing about those sorts of platforms is that in very poor environments where there are no televisions, you can use them. So they themselves are more expensive and more complex and harder to build. There's no way I could ever have built a laptop. I was able to build this. This is just a bare PCB, right?
So
that's an order of magnitude easier to build
than
the tablet.
My
So
question, sorry, even to interrupt you. My question is, can this talk to an Akash tablet, and can a very poor child have a portable computer? I mean,
so no. I think the answer, using this platform, we're trying to target an audience who have televisions. So we're trying to target an audience who have people who've just built, and there's a large market of people who've just bought their first television, right? For I think people in the developing world, for people in the developed world, your television is still probably the most expensive piece of electronics you buy for a lot of people. I spent more money on my television than I've spent on anything other than a car, right? The idea here is if you've bought a television, it's absolutely not for the poorest people who don't have reliable electricity and don't have a television. I think those people are going to need tablet-like solutions, or they're going to need laptop-like solutions in order to get a display. This is a much cheaper solution for people who have a little bit more. So for people who already have a display, and that's we're trying to kind of piggyback. People have made an investment in a television. People have made an investment in a display. And what this is trying to do, just like the computers that I grew up with as a child, they try to piggyback on that and get you a little bit more for your money. So you've paid $100 for a television, you pay another $25, and your television becomes a computer. That's the kind of model that we're trying to pursue here.
okay.
I hope that answers your question.
Yes, it does. And just one last question from my side. Why is it so cheap? Is it? I mean, okay, I work for Arduino, and just a curiosity from a user's side. Why is it so cheap? I mean, $25 is a very, very good price. Or is it a trade secret that you cannot divulge? Just a curious question.
So you're saying how did we make it so cheap?
Yes, because I work for Arduino, and
Okay.
I've seen them
So-
handle the project. So
I don't think it's a trade secret. I think that what we have done is we have deliberately avoided. We've been very aggressive about removing features from the platform unless they are absolutely needed. So we had the idea we need a certain amount of RAM. We run Linux. We're a Linux PC. So we needed enough RAM to run a good Linux desktop. We needed enough processing power to run a good Linux desktop. We needed enough multimedia to make it exciting for children. And we needed to be able to connect it to a network, to a mouse, a keyboard, and a television. And what we've done, if you look at the board, I mean, it's kind of hard to see. You could maybe go to our website and have a look. If you look at the board, in the middle here, you have an SoC. You have one SoC here. You have a support chip here.
right.
And pretty much everything else on this board is just connectors, right? So by being we found a good SoC. I work for, my day job, I work for a company called Broadcom. We found a very, very good Broadcom SoC, which was both very cheap and very high performance. And most importantly, which integrated a lot of the features into a single piece of silicon. So we have our HDMI and our composite and our USB, everything basically apart from our networking, everything apart from Ethernet is on a single piece of silicon. So we have one SoC, we have an Ethernet chip, and we have 256 meg of RAM. And everything else on that board is passives or connected. And so that's kind of the secret. I mean, to the extent there is a secret, I think the secret to building platforms like this is to look at every component, design it, and then go and look at every component and ask if you would be prepared to throw that component away. I mean, it's what we all do, right? I mean, it's our jobs as electronic engineers to work to a cost target. And so that's what we've done here. And we've been very successful.
Thanks a lot. It was nice.
Thank you.
Are you able to hear me?
I can, yes.
Okay. You touched upon one laptop per child project. That project also had a very good interface from Sugar Labs. Does Raspberry Pi have that interface ported onto this? That was very much suited for the child education.
Yeah, user interface for children for learning is a really nice user interface. It's very low. It's very resource light. It's a very lightweight interface as well. Up until now, we haven't. I mentioned that over the next year, we are hoping to spend more effort on this platform, on the software side of this platform, and improving the platform. And that's one of the things we want to do. One of the things we want to do for the education market. We know at the moment there's nothing educational. We said, we're an educational charity. We made this thing. There's nothing educational about this, right? This is just a Linux PC. It's no more educational than a $500 Intel Linux PC. I think that really what we have to do as a foundation is we need to do exactly what One Laptop Per Child did, which was to think very, very hard about what sort of software environment will make this attractive to children. Now, I mean, One Laptop Per Child was not enormously successful, but what they were good at was offering an integrated educational story, and we do need to do more of that, and it's somewhere where we are weak at the moment. And the community has been very helpful to us. One of the lovely things here, this is a completely open source design. The community has been extremely helpful to us in identifying software improvements. I think this device, as a result of community effort, has become 4 times faster since April. In some areas, this device has become 4 times faster simply through contributions, software contributions. People have identified one small but worth fixing hardware error. We released the hardware designs for this, and we got an email from somebody who said, we don't think you've wired this component up correctly. So there's the community's been very helpful, but yeah, I think the foundation is going to focus on exactly what you say, on offering a much better user experience to children.
I think the combination of sugar and this will be the ideal, because I think the roots in which you have mentioned why Raspberry Pi came and sugar, they have a good combination. Thank you.
Yeah. Yeah, we hope so. Thank you.
Hi, Doug.
Yeah, they're always very careful not to talk about future devices, because there is the risk that if I told you that you could buy one of these which was 10 times as good in 2 months' time, you wouldn't buy this one. So, I guess, maybe you would. It's quite cheap. So we don't actually, as it happens, we don't have any current plans. We do realize, obviously, that we can't. This uses an ARM 11, right? So this is on the processing side. It's got very, very good multimedia, but it's got only kind of medium performance general purpose processing. So I'm sure that we would love maybe in 2 or 3 years' time, it's going to get to the point where this is an ARM 11 based platform is not going to be acceptable for people, and I think at that point we will probably try and develop something more powerful. I think in the next year, there's still a lot of performance improvement available in software. There's a lot of performance improvement available by tuning the software in the device. And that's what we're focusing on. So, and the nice thing about that, of course, is that if we do it all in software, if we concentrate on software rather than hardware, then all of the people who've already bought a device, all of the people who've already invested in this platform, can benefit from that. So we're not leaving anyone behind.
Yeah. Okay. Thank you.
We've committed to support this platform for a minimum of 5 years. which is very important for people who want to design this into industrial products. It's extremely important for them that they have access, that they know we're not going to abandon this platform. So even if we do, maybe in 3 years' time, do a new one, we will continue to sell this one to support people who've designed it into industrial apps.
When you said you're looking at school children using it, now I'm clear when I actually saw a demonstration of Pi, but what I can see it is start interfacing it with what's readily available. I've not actually seen on the net as what's readily available, but I believe most of it is on a 3.3 volt than a 5 volt, which can be easily bought off store or can be worked around with, can be played around with people with less experience. So what is there to just give that extension there?
So I'm extremely bad all of a sudden. Were you asking about interface? It sounded like you were asking about interfacing.
Yeah, I'm looking, when you said you designed it for school children, I'm say probably a 10 or a 12 plus around there, just before they come into graduation. What are the things that focused at that apart from a media there? What is your plans regarding getting something out for there? It could be something like a kit or just an interface, a better interface than a 3.3 there.
Okay.
Some kind of a protection.
So this is kind of funny because I'm a software engineer. I was a software engineer. I used to be a software engineer. I'm now an ASIC engineer. My interest in this platform has always been a software interface interest. Right. I've always been interested in software. And so when I was thinking about this device, I thought, well, let's make sure the software is really good. Now, as it turns out, but because we have it's an SoC, it's designed to go into a phone. Phones need GPIO. It has a bunch of GPIO. And we brought this GPIO out to this connector on the side here. It turns out that almost all of the coolest things that people have done with Raspberry Pi have used that connector. Almost all of the coolest things have not been software things at all. They've been hardware things. And I guess, if you look at platforms like Arduino, which is Arduino or Embed, these platforms that are very cheap, but they're just microcontrollers. People are, young children are doing really impressive stuff with them. So interfacing is really important. There are ways in which we are less powerful as an interfacing platform than Arduino. There are ways that we're more powerful. So I've seen, here's an example. There we are. Can we see this? Yeah, so this is a Pi underneath. And that's an interfacing board on top that was built by a university here in England. And I think this thing here is a PIC. It's got a PIC on there. So people are already doing very large amounts of interfacing work with this platform. And I think it's very exciting. And I think that actually, in terms of interesting children, children like playing with Lego. Children like playing with blocks. Children like things they can touch. I think the physical computing.
So what is available as such to interface it for children, I'm asking?
Okay, so what's available for children to interface to it?
Yeah.
Okay.
It could come there.
Well, so there were quite a lot of people. We've had some success interfacing Lego to it.
Okay.
Which I don't know how popular Lego is in India, but in the UK, Lego is still one of the most popular children's toys. Okay. So we've had some success, and they have normally a PC-based platform for children doing interfacing. So we've had some success integrating it with Lego. We've had some success. We've had some success doing what we call citizen science projects. So, where a number of schools can participate in some science experiment. So we had some people doing high altitude ballooning. So putting one of these with a camera, putting in a balloon and sending it up to 40 kilometers up in the air. We've had children using them to photograph wildlife. So there's lots of these things that get children. They aren't pure engineering, but they get children interested in doing things like engineering. So I guess those are examples, but it's very early days. We're only 5 months in. Okay. We expect to see the really exciting stuff over the next 12 months.
Thank you.
Thank you.
A bit curious about it. What's actually behind this name, and why do you choose Raspberry Pi? What's behind it?
We had
Apple.
we had a company we had companies in the UK called Apricot. There was a company called Tangerine. There's a company called Acorn, of course. Acorn is technically a fruit. there's a famous company in California whose name I forget. So there are a lot of fruit named computer companies, and there aren't that many fruits that are left. And so we picked raspberry because it's also, I guess raspberry is also British. I don't know if it's slang in India for kind of like sort of noise, right? Blowing a raspberry, like kids do sometimes. So yeah, we thought it was funny. We thought it would be a funny name. And then pie, well, we thought it'd be nice because it goes with Raspberry Pi. And we thought that the letter, the Greek letter pi, would look good in graphic design. We thought that it would be a really strong graphic design element. As it turns out, we've never used that. So our logo was designed in a contest last year. And all of the people who submitted logos that actually used a pi symbol didn't look any good. So we have a logo which is just a picture of a raspberry, a very stylized picture of a raspberry. But that was our idea anyway. So it was kind of a joke. I hated it for the first year. I really hated the name, and then I came to love it over time. But it was somebody else's idea.
And even just one more question. Like, I'm basically into robotics. Okay, so we use basically few of us use Arduino boards and all that. But I want to know how Raspberry Pi can be used in robotics for children, especially to bring robotics. Like we have a program taking technology to little hands. Okay, so that we take up robotics. We teach robotics to children. We get them interested in engineering and technology, especially robotics. So I want to know how we can use Raspberry Pi as a tool to get children more interested in robotics.
So one of the nice things about platforms like this, so this thing here, let me just take this apart. So that's a Raspberry Pi, and this is the thing that I just showed you that's on top of it, with the relays and stuff, and they then fit together like this. The nice thing is that there are lots of these boards available for doing sensing. I mean, I guess the two things you need to do in robotics are sensors and actuators. So there are lots of these boards that combine sensors, actuators, maybe some PIC-like logic. So I think very, very simple robotics you can do just using a Pi, because we have digital I/O, low voltage digital I/O. So a Raspberry Pi in effect will give you some sort of motor controller. I think that these platforms like this are extremely useful for doing robotics, and we're seeing children doing robotics. Often we see it's not part of the formal school curriculum, because we have a very defined curriculum in the UK. So schools don't have a lot of flexibility to do novel, innovative things. But what they can do is they can run after-school clubs, and we have like the Boy Scouts. We have after-school clubs at school, and that's a place where a lot of people are doing robotics with these applications, with this platform, because they've got freedom. They've got the freedom to do it. They've got a little bit of money. And so we actually think, although we are all about education, we're much more about children and about voluntary organisations than we are about schools. And I think that will always be the way it works for us.
So like, can we interface any kind of sensor with this with Raspberry Pi? Like we use basically PI sensors, IR sensors.
Yeah, absolutely. So you can interface. You can either interface directly to the sensors from the Raspberry Pi, or what we have seen some people doing is using an Arduino.
Okay. Now, do we have the ports? Any particular ports as such?
Can you say it again?
No. I was saying, for interfacing these sensors, like, are there any specific ports or any such thing on Raspberry Pi? Because I've never got to see one. That's why I'm asking.
Oh, okay. So you're saying, are there ports for connecting to sensors and actuators?
Yeah, exactly.
Okay, yes. So we have, just get this here. It's very hard it's actually quite hard to see if I maybe show you from side on.
Okay.
You can see a row of gold pins here.
Yeah.
It's a row of gold pins. Yeah, so we have a 26-pin, 0.1-inch header on there that's specifically for that purpose. So this gives you about 20 GPIO lines, general purpose I/O lines. It gives you I2C and a UART, SPI, all at 3v3. What it doesn't give you, the big thing you don't get with our platform that you would get with an Arduino, is we don't have any analog input.
Thanks a lot, Eben. Thanks a lot.
Rock conference, there was some talk during the conference about learning electronics design. One of the things being, learning to do one's own board. Are there other spin-offs of the board? Do you recommend that? Do you see people taking your schematics, or are your schematics public? And are people taking it and adding other things onto this board and making their own platform?
Of the technology.
Well, no. Are there people taking the fundamental schematics of your board and making their own PCB with additional components?
Okay, yeah. So at the moment, we release the schematics, the high-level schematics to the board. We don't release the Gerbers. We don't release the board design yet. That's not because we don't want to. It's because we want to port it to a cheap package. So this thing was designed using Mentor Graphics Expedition, which is, as I'm sure you know, enormously expensive, right? So we want to get the designs and port them so that they run on a much cheaper CAD package before we release them. Preferably a free CAD package. I would like to be able to run them on Design Spark or Eagle, one of the free CAD packages from our partners. So far, no, people haven't done that. I think that people will do. We are hoping to release the schematics in the next couple of months. And once we do that, we expect to see a lot of people producing small numbers of devices. One thing we expect to see quite quickly is power over Ethernet. We don't support PoE. We expect that pretty much as soon as we release it, we will see a PoE version from someone else, and that'll be a good thing. We're a charitable foundation. We can't make money from this. We're doing this because we believe that it's very important to get another generation of children programming. So we don't mind if somebody wants to go make money from this platform. We really don't mind, and so that's why we'll be releasing the designs. That's why we will be very happy when we see other people's variants of this.
That's a really good idea. I'm sure Broadcom will be happy if more people make
of
yours.
Yeah, I mean, Broadcom, we should say Broadcom have been enormously supportive of this project. We're extremely grateful to Broadcom for their help with this, and we do hope that it'll help popularize Broadcom. Broadcom have a big range of chips. We do hope that this will popularize those chips among a new generation of programmers.